So the first 4 calculations are really nice and easy because they've all got the same denominators. So it's basically saying I've got 1 of these type of fractions and I'm adding another 2 of the same type of fractions. So I've got 3 of that type of fraction. Same here, 1 of 7ths, add another 4 7ths, gives me 5 7ths. Subtraction, same idea but with subtraction. 8 ninths, take away 4 ninths, leaves me with 4 ninths. Notice we don't add or subtract the denominators. They are describing the type of fraction, they are not telling us the size or how many we've got. 7 take away 1 is 6, 8. Now these ones we can't do in a similar way because they've not got the same denominators. So here we use the notion of equivalent fractions. So we need to work out, can we make these denominators the same? Well, I can't turn 12 into 2 because I can't turn 1 and make 1 any smaller. But I can make 2 into 12 because 12 is in the 12 times table and the 2 times table. So I'm going to make both of those fractions 12ths. Now if that's 1/12, how many 12ths is it? Well, it's 1/12, isn't it? If that was a half and it's now 12ths, how many bits have I cut each half into? Well, from 2 to 12, I've multiplied by 6. So I multiply the numerator by 6. What have I got? They're both 12s, that's very important. How many have I got? 1 add 6, 7. Excellent. This one, 3 and 21. So I need a number that's in the 3 times table, a multiple of 3, and a multiple of 21. Luckily, 21 is a multiple of 3. So I can make both of these fractions over 21. So if I've got 1/3, and I've now got 21, so I went from 3 to 21, that means I multiplied by 7. It means I need to multiply the numerator by 7. 1 times 7 is 7. What did I do here? 21, 21. What did I do? Nothing. I didn't change it. That's why I don't change this. 2. They're both 21. 7 add 2 is 9. Here we need a number that's in the 20 times table and the 5 times table. 20 is in both of them. 17 20ths is 17 20ths. 5 has been turned into 20. It's been multiplied by 4. 2 needs to be multiplied by 4. 17 take away 8 is 9. 9 what? 9 20ths. 7 over 10, add 27 over 80. We need a number in the 10 times table and the 80 times table. I'm going to go for 80 here. All of these, you use one of the denominators that's already there. 80 is already 80, so 27 stays as 27. But what have I done to 10? 10 going to 80, I've multiplied it by 8. Do the same to the 7, 56. 56 add 27 gives me 83. Leave 80. Oh, hang on, that's not worked, is it? Because it's given us 3 boxes for our answer. Which means we don't want it as a mixed number. That makes sense. This is a top-heavy fraction, an improper fraction. So, how many is a whole one? The whole one is 80 80ths. But how many extras have I got? 3. I've got 1 whole one and 3 80ths. Changing both denominators. Right, so this time we know it's not going to be 5 and it's not going to be 8. So we think about our 5 times table, we think about our 8 times table, and we look for a number that's in both of them. 14. But what have I done to 5 to get 40? I've multiplied it by 8, so multiply 1 by 8. What have I done to 8 to get 40? I've multiplied it by 5. I also multiply this by 5. Add them together, 23, 23 over 40. You notice these are worth 3 marks, whereas the previous ones were only worth 2 marks. 8 and 12. Think about your 8 times table, your 12 times table. 8, 16, 24. 24! There we go, 24. Okay. What did I do to my 8 to get 24? Multiply by 3. So multiply by 3. What did I do to 12 to get 24? Multiply by 2. 13 in total over 24. A couple of subtractions, exactly the same idea. 10 and 15. Both of those have got 30 in their set of multiples. I've multiplied that by 3. Multiply that by 2. Giving me 13. Took a second there. Still 30. 9 and 7. 63 is our best answer there. 56 because I've multiplied by 7. 18 because I've multiplied by 9. 56. Take away 18 gives me, gives me 28. That's an absolute lie. No, it isn't. Oh my goodness me. 38. My goodness, Mrs. Ward. Try again. There we go. That's better. This is why you need to watch out for silly mistakes. So, write your answers mixed numbers. Let's have a look. We've got 5 8s, 7 12s. We already know that 8 and 12 can both be used as 24. Multiply that by 3. Multiply that by 2. 29 24ths. Well, that's one whole one. And how many left over? 5 left over. That's one whole one. 5 24ths. Let's look at this one. 5 and 7. The multiple of both of those is 35. I've multiplied this by 7. I multiplied this by 5. Which gives me 53 over 35. So it's more than a whole one because a whole one is 35 35ths. How many extras have I got? 18 35ths. I've got one whole one and 18 35ths.